I would request the event team or anybody who's present here who's managing the hall to please remove all these chairs. Yours is third. All right, ladies and gentlemen, so we are about to start the fourth session for today's conference, and it is about capacity building and human resource management. And our first keynote speaker is Mr. Ranjan Bandyopadhyay, Chief Human Resource Officer, TEPL. He's going to address on the capacity building. Sir, I would request you to please come on stage, and I think we need to give him a big, big, big round of applause for the kindness and humbleness that he has shown here right now.
Thank you.
That's what is a quality of a great, great, great leader. And if you may allow me, I would like to introduce you. I have a few lines to say about you.
Don't worry, don't worry. I think we are running short of time. People are very, they have their flights to catch.
Right,
But I
so
think, yeah.
the stage is all yours, sir.
If
Thank
we
you.
can, get the presentation up. Don't worry, you can keep it. Anyway, Dr. Anand is gone, and I was wondering, he was talking of 30,000 chips a day. We are talking of 50,000 chips a day, 1 billion chips a year, and the kind of water, I don't know, that we are going to use. And 20,000 technical jobs. All these are fill-ups till my the presentation comes up. So 20,000 jobs and 300 fab with 110 to 28 process nodes. My presentation will be primarily three. I'll be talking briefly about the pioneering spirit of the Tatas. Where do we source people from? Transference of making people productive, and ecosystem creation and leverage, and the support of the government. I think we can go to the next slide. So I'll quickly go through what Tata, in terms of our pioneering spirit, we have been doing. If you look at whenever the country needed something, Tata's was there. We were the first one to create the textile industry in 1874. We were the first one to introduce air condition in hotels. We were the first one to start the Tata Cancer Research Hospital. We also were the first to start the indigenous car made in India. And now is the time for electronics. We started in 2020 with the components business, post which we were in final assembly and test. Then we came to OSAT and now in fab. So fortunately for us, we are a big company. We have almost 45,000 people today and in 6 locations. This is what the press has been talking about, and there's been a lot of coverage about us everywhere for all our different business units. This one, I thought I'll just talk a little bit about the agile world. All this while, if you look at craftsmanship, it's hereditary, meaning it's been transferred from one generation to another. And time for us to look at agile ways of managing processes, managing attention to details is something that we need to go through. This is the semiconductor market, and like somebody said in the morning, India will be the fastest user of semiconductors by 2030, and the amount of money spent would be around $110 billion. Right? Now, we all spoke in the morning, I think the third session, we were talking about a lot of design engineers and how we lack process engineering capabilities in the country and what needs to be done. And like all of us know, a good talent, without talent, company is either good or dead, depending on the talent that they have. Now, where is the talent? If you look at the talent landscape today, you know, in this slide, I want to talk on two things. One is the supply chain aspect. Second is the talent chain aspect. In the supply chain aspect, the entire ecosystem. Sorry, can I get that mic? Handheld mic. This is very, yeah. Thank you, thank you. So if you look at the market today, the supply chain, the semiconductor, the capital equipment manufacturers, the design is from America. Then the foundries are in Taiwan. Then the OSAT is in Southeast Asia. The components and final assembly is in China, Taiwan. And then the finished product goes back to America. There's huge country movement, and like somebody spoke about COVID and how the supply chain was impacted. The entire universe for Tata Electronics is to shorten the supply chain time, the time to market that we call it. And the market, the talent is available in these countries. So if we have to attract the talent in these countries, what has to be done is something that I'll be talking about in the next few slides. So for building capacity, like today at this point in time for our OSAT business, we have 106 people. Of the 106 people, 70 are from Southeast Asia. In our foundry business, as a seed team, everybody, 100% of the population, that is 27 people that we have today, are all from America, all right? So I'm just in capacity building. The starting point is a seed team, and seed team does not exist in India, and we have to get the seed team. Today, as we speak, we have recruited 120 engineers from different IITs, NITs. Of course, from Gujarat, we have recruited from IIT Gandhinagar and MS University. And we have trained them in Indian Institute of Science. We have trained them with IIT Bombay and Synopsys. And we are sending them for international training with our technology partners. And they'll be shadowing the global experts there. But in the long run, this is something very interesting, because if we are to start a BTech program, let's say in material science or in semiconductors or something, it'll take 4 years. If we start in 2025, in 2029, the first batch will graduate. Till 29, what should be done will come in the next page. But curriculum has to be enhanced. We also have to go to schools and talk about the growth aspects of semiconductor to create the ecosystem. Academic councils need to be created. All that, since morning people have been talking about it, the most important aspect is to have dedicated labs. And I think that's going to be a key differentiator. Industry internship and scholarship, of course, without that will not happen. Our intent, the core objective, is primarily to create the right ecosystem. How do we empower our employees to become entrepreneurs? How do we encourage students to be entrepreneurs? How do we ensure that it's not only, semiconductor is not only for IITs. Semiconductor has to be for Tier 2, Tier 3 engineering colleges. And how will Gujarat as a state lead this from the front? It's not going to be any other state. This state is going to lead. My thoughts is on the next page. There's something we have been, thinking about. Like I said, in 2025, we start a BTech program. 29, there'll be the first batch of students. Till that time, what do we do? Today, at ABC, it could be IIT Gandhinagar, it could be anything else. But ABC is a university, and we are thinking of different models. How do we, because Gujarat has 250 engineering colleges, how do we take the top talent of Gujarat and train them in ABC? How do we create labs in ABC? How do we look at creation of, even clean rooms and things like that? Finally, the intent is Gujarat to lead for India, because it's not only in 2026, 27, one fab from Tata. There'll be, there are a lot of fabs will get created, and there'll be other companies also coming in. So India ecosystem needs to be created, and the seed has to be from Gujarat. So these are the thoughts on Some thoughts on the curriculum. This is what, because it's a completely multidisciplinary approach without AI, without chemical, without mechanical, without metallurgy, without applied materials, not as applied material as a company, but materials, material science. Without construction, it's not going to happen. Now we are talking about the entire gamut, and this is something which we have been thinking about. Of course, there need to be factory physics. You have to have lots of chemistry. I have not mentioned supply chain and some aspects of business that has to be trained in the engineering courses. These are some of the thoughts on what could be a probable curriculum. It's very broad-based. It needs to be made much more granular, but this is just the first thought. This is the most important aspect for us, because one thing I have not mentioned here, and before that I want to talk about one very famous company in Southeast Asia. In the year 1993, they recruited all the PhD scholars in most of the engineering subjects, paying them American salaries that they would have got in America, bringing them to their country, giving them accommodation, transport, free food. This happened till 1999. And now they are #1 in the world. I don't want to name the company. I don't want to talk about it. But that's what the government did, 93 to 99, top salaries of the world, house free, transport free, food free, everything free. Now that's how they created the ecosystem. For us, when I went to Semicon last week, in each session, they were talking of talent shortage. And I felt very happy, because we are not only thinking of talent shortage, everyone else is. Our advantage is they don't have talent. We have tremendous talent. We have hundreds of youth, hundreds of engineers, and by the way, not everybody will be an engineer who will be working here, right? We have opportunities for class 12th girl people, for diplomas, for BSc, physics, chemistry. And the entire ecosystem that will open up will, for us, we are thinking of a ballpark 20,000 number, but that's how it'll get created. Now, if we have to think of Dholera, I don't know if anyone's gone to Dholera. I've gone there 10 times. There's nothing. Dholera has to be like Dubai, right? Otherwise, why should any international hire come and work there? What is in it for them? There has to be good schools. There has to be bump-free roads. The first session, it was covered. Everything has to be absolutely world-class. We can't say, because we were used to roads filled with potholes, you should manage. Then God only will save us. India, time for us to create the right social infrastructure in Dholera, having metro rail, having airport, having the best of a best. Even Dubai plus, meaning Dubai should be following us in Dholera. That's the kind of social infrastructure we need to think of. We also need to think of two other aspects, very important aspects, is for bringing in expats, because we need almost 10 years we have to bring international hires. After that, we'll have our own people do everything. For this 10 years, how do we help with the taxation? Everybody is bothered about the taxation in India. We have to have the right taxation policies for the expats when they come here. I don't know who will think, but our team, we will represent and lobby for the international hires, for making them, feel at ease in this country, for their kids to come and study, for them to make some money, because finally they'll come. Why should they come to India? They can stay in America, they can stay in Taiwan, they can stay in any place. They'll come here to make money, and I think we should give them that opportunity, because here's an opportunity for all of us. So that's pretty much it. And last thing is, in Dholera, I think this cultural integration is going to be very important, because what happens is at times, looking at people, we make some unnecessary comments, and all that sensitivity amongst the people who are in Dholera needs to be developed. So thank you very much. I'm done before time.
Thank you so much, sir. Thank you very much. I would request you to please stay back on stage because you have graced this event, you have graced this seminar, and you have given such an amazing presentation. We have a small token of gratitude for you. So I would request Dr. V.S. Purani, Chairman, Technical Examination Boards, to come on stage and felicitate you. Let's give a big, big, big round of applause for our speaker. Thank you so much, sir. Our next speaker is going to talk about talent development for semiconductor ecosystem. And I would like to call on stage Dr. Raja Gopalan Pandey, Assistant Professor and Program Lead, NAMTech. Dr. Raj Gopalan Pandey, a faculty member at NAMTech's Department of Semiconductor Manufacturing, has an extensive academic background, including positions at National Cheng Kung University as a Chiangnol postdoctoral fellow at, wow, sir, very difficult names, but I would try my level best to stick to the right pronunciation. Zhejiang University, honored with the NSFC Distinguished International Young Scientist Award. He has also held fellowships in China and South Korea. The stage is all yours, sir. Thank you.
Thank you, ma'am, for the warm welcome. I stand before you with a great humility, recognizing my journey has just begun. I'm sharing the stage with many of the stalwarts of industries, and you are paving and already have paved the advancements which we are celebrating today. Your contributions has set the foundations upon which the present generation, including myself, will continue to build upon. With this, I would like to start my presentation with a famous quote from Dr. Maurice Chang. He's a founder of one of the leading semiconductor companies, TSMC. Without strategy, execution is aimless, and without execution, strategy is useless. With this in my mind, I am grateful to the Gujarat government, Government of India, GSEM, DST, for facilitating this event, for the unwavering commitment, for the policies they are implementing, and they are working on both execution and strategy, bringing innovation to Gujarat, solving two problems: the sustainable development, which we said in the previous session, and also working on the ecosystem development. So I would like to start my speech with a story from, again, Maurice Chang. In 1980s, he was working for Texas Instrument. And Texas wanted to set up a factory in Japan. When they set up a factory, after 3 months, they realized the yield in Japan was twice that of Texas. And Dr. Chang was given the chance to find out the mystery. When he reached Japan, he found many reasons. But one of the important reasons was the workers' commitment to the company. The other important aspect which he realized, and he predicted, that the future of semiconductor industry, because of only this factor, will be in Asia. And with this aim in mind and the problem of this session on developing the workforce ecosystem, here I present my problem. We see the world of workforce development in two aspects. There is a world of learners and there is a world of work. We have 4 years engineering programs, we have 3 years diploma programs, we have 2 years of ITI certification programs. And based on recent reports, it has been found that majority of our engineers which has been produced are not employable, are not industry ready. Hence, to scale a bolt on the employability, NAMTech was created. We are a non-profit organization funded by two of the world's largest steel manufacturers, the ArcelorMittal and the Nippon Steel. We are not in the diamond mining business, but we are in a diamond polishing business, which means we polish the engineers or the technicians or the diploma engineers which are coming out of our industry. We polish them to industry ready. In the morning, there was a session where Dr. Ravi was mentioning about a very, very important point. He said, this is not the era of skill development. It has to be a domain development. And hence, NAMTech is working in that spirit, where we polish and train the engineers in the specific domain roles. Our vision is to create 100+ industry-led labs. For the world of learners, we say that we give industry-aligned curriculum, experiential learning, flipped classrooms, state-of-the-art phygital campus, and strong academic partnerships. I'll talk about the strong partnerships we have built with industries as well as with academics. And for the world of work, we include them for training. Some of the speakers in the morning were asking this question from the back, that how about the faculties not only come from academia background, but also from the industry background. We understand that need and we work on that. Not only that, there is a huge gap in terms of lab infrastructure when it comes to production facilities given to a student and when it sees the industry for the first time. We at NAMTech believes in state-of-the-art equipment, and hence we create a laboratory at a production level. We collaborate with applied research. We apply mentorship programs, internships. The previous speaker on the dais were mentioning about the internships, and yes, we take it very seriously. Our students work on industry-driven programs, which are co-mentored not only by academic faculties, but also from the engineers in the industries. And we solve real-life problems. We are structured in 5 schools as of now. School of Manufacturing Technology, which is operational, working on smart manufacturing, one of the best syllabus, not only in India, around the world. I have been working in China, South Korea, Taiwan, Singapore, and India. And I can certainly say in smart manufacturing, we have one of the best syllabus. I am heading the Department of Semiconductor Manufacturing, and I'll talk briefly about that in my subsequent slides. So the School of Semiconductor Manufacturing is based on all the principles which I already told, but in the previous session, there was a speaker, Dr. Kinjal. He was from NTUST, Taiwan. I was a professor at NCKU, and there was one buzzword which has been coming on and on, which is Hsinchu. Hsinchu is the heart of Silicon Valley in Asia. Because of my experience in Taiwan, and with the blessings of our leadership, we went to Taiwan. We forged the partnership with some of the leading universities there, Taipei Tech, National Taiwan Normal University. We already have a partnership with Technical University of Munich, Asia. In the heart of semiconductor industry, Hsinchu, there is one organization called Zhejiang Foundation of Science and Technology, which is an industry leader in training these courses, especially the semiconductor courses. We partnered with them. The previous speaker has mentioned that they are facing some problems in training students. So they hired very good engineers from Indian Institute of Technology, Gandhinagar, and some other universities in Gujarat. We at Namtech wants to bring a change where our industries do not have to go to other countries to train them. We want to build those facilities right here in India, right here in Gujarat. And sir said, seed is to be from Gujarat, and I can proudly say, seed is from Gujarat. In a brief span of 2.5 years, we have forged a partnership not only in Taiwan, but other global academic leaders like MIT, Carnegie Mellon, and we also work in vocational training for ITIs and diplomas. And one of the best institutes in the world is ITES Singapore. We have forged a partnership with them. Colorado Schools of Mine, TUM Asia, Arizona State University, Purdue. These programs, it's industry driven and also academically driven. So students have multiple options according to the National Education Policy of 2020 in India. So they can continue the project, they get the diploma, they can have an option of 1+1, where they work here, the credits get transferred, they go to US, they complete their masters. We work on the curriculum as well. So some of the key aspects of our semiconductor manufacturing course is dedicated to ATMP facility, which we are witnessing throughout the day, the assembly, testing, marking, and packaging. We understand the need of companies, and hence our partnership with Micron, as today rightly mentioned by Senior Vice President Shri Gurcharan Singh Ji, that we have forged a partnership with Namtech. We are co-developing the course curriculum in ATMP, focusing on process engineering, testing, metrology, AI in semiconductor, reliability, statistical process control, yield engineering, operations and supply chain, systems engineering, etc. And these are to cater the roles such as assembly and test process engineers, material specialists, product reliability engineers, electrical failure analysis, physical failure analysis, process control, fault detection, etc. And we call our labs as a maker's backyard. And we are committed to build these kind of equipment, production level equipments at our facilities right here in Gujarat, right here in Ahmedabad. We also, with time, will move into the process engineering roles for manufacturing, for fabrications. And hence, we want your help in building this, especially from the industries, to collaborate with us on the student trainings, student projects. If you want domain design curriculum, you can reach out to us. And that's all from my side. Thank you so much.
Thank you so much, sir. Now I would request Dr. V.S. Purani, Chairman Technical Examination Boards, to please come on stage and felicitate you. Thank you so much for that lovely presentation. I'm sure we have got amazing insights from that. Thank you very much. Let's give a big round of applause for our speaker. Our next speaker is going to talk about skill development. And now, I call on stage Dr. Ashwini Agarwal, Senior Director, Government Affairs, Applied Materials. Dr. Ashwini Agarwal, Director of Government Affairs at Applied Materials India, manages policy and development for sectors like semiconductors and solar, with a rich 30-year career including 18 at Hewlett-Packard and strategic role at Omnicom Media Group. He's respected figure in ESDM advocacy, contributing to IESA and ELSINA. Sir, the dais is all yours. Let's give a big round of applause for Dr. Ashwini Agarwal.
Okay, can you hear me? Are you awake? Ready? Okay, great. Hi, this is Dr. Ashwini Agarwal. I will be taking you through a few messages on developing the semiconductor workforce in India. And I'm actually taking this presentation not just as an applied material lead, but also as the chairperson for Semiconductor Skill Committee at Electronic Sector Skill Council. So I'm associated with Electronic Sector Skill Council for the last several years, and I've been contributing to their tech curriculums. This session will actually focus on that. And I would like to start with one key message, something which has already been captured by some of the previous thought leaders on this subject. But I want to be very clear. Semiconductor design is not semiconductor manufacturing. So many times, people confuse and say we'll do more VLSI courses and that will be actually bringing our country up to speed on semiconductor sector. Sorry, semiconductor manufacturing is a totally different set of skills. You need people who should be, capable of handling process equipment. You need people who are capable of creating a plasma in a chamber, okay, controlling it, identify issues in creating it, okay? You need people who can create an ultra-high vacuum, who need to understand what are the safety implications of all the chemicals, what are the hazards of all the chemicals that they are handling in the fab, okay? This is a very manufacturing-oriented industry, okay? This is what we actually need to build skills on. We already have a very significant design competence in the country. That's a strength. But that is not what will take our semiconductor manufacturing sector ahead. That is not what will power your CG project. That is not what will power the Tata's project. You need manufacturing engineers out there. So if you actually take a look at it, Electronic Sector Skill Council actually addressed this in a slightly different way from what was originally planned by the AICT. Okay, AICT is also incorporating some of our suggestions now, but we are very clear. You really must recognize that semiconductor is a multidisciplinary field. You have every engineering there on the shop floor. From electronics engineering to mechanical engineering to chemical engineering, you have every engineering person on the shop floor. What you really need is a base foundation degree, and you need polishing with the right certifications on it. How do these skills build up? They build up something like this. What we feel, you have a foundation degree, and then you start adding your additional certifications, and depending on the combination of certifications that are taken, the person moves from a workmanship cadre to a specialist to an expert cadre. A simple example that I would take is, let's say, safety. Safety is one of the most fundamental aspects of engineering, and definitely of semiconductor engineering. So if somebody's taken a specialization in handling chemical safety, he's an HASCAM safety specialist, or a HASCAM safety technician. Somebody who's taken the skill sets to handle electrical safety, he's an electrical safety technician. Somebody who's done mechanical or factory operations safety, he's an appropriate technician for that particular cadre. And when somebody has done all of it, he may become a specialist. If he has earned a few years of experience, he moves to an expertise rate. So, and then he has to, periodically do ongoing validation. And that is the way the skill foundation for the semiconductor sector is being created at Electronic Sector Skill Council. If Parashi can show the two documents, this is, just scroll it up. This is a document which actually defines what is a skill certification like. And if you go down a little, go up, you will actually come. You actually have to define these ones. Has a person completed a procedure on his own? Has he completed it in a group? Has he passed a written exam? Has he done a demonstration of some skill? Has he actually cleared a viva? And these are recorded on the next checklist. And if you go on to the next checklist, ideally to the page 4, okay, we get into a lot of detailing. The person has to actually, for example, if it is vacuum technology, okay, he has to know the theory of it. What is the mean free path? What is actually the conversion between a torr to a millibar to a Pascal? Okay, but it goes beyond. What is the rotary pump you're handling? What is a cryogenic pump? Okay, what are the parts of those pumps? What is the, how will you create an appropriate vacuum pumping system? Okay, what are the defects? How do you measure vacuum? Where are the, how do you detect leakages? Why is your vacuum not getting created? What is the, why you can't use anything other than a specific grease, a silicone grease, versus using a hydrocarbon grease on the vacuum pump? How do you extend the life of your evaporation boat? There are so many technical skills that are required, which are normally not covered. And we want to cover that in our skilling program. Paraji, go to the doc file. Oh, you're already there. So this is, for example, another one, the industrial safety for semiconductors. We have actually, this is not just a national occupation standard recognized by the MSDE now. It's also now included in the AICTE program that is being rolled out by the Ministry of Education, AICTE. So this clearly says there are different units, HASCAM safety, electric safety. People have asked me when I was writing it, why are you having arc flash safety in a semiconductor program? And that's because you have ion implantation machines which are handling 40,000 volts with ions getting accelerated and striking substrates. And if there are people who are going to handle high voltages, or equipment using high voltages, and they don't understand what they are dealing with, you will have disasters. You have crazy hazards in a semiconductor fab. You'll be handling gases like silane, diborane, phosphine. In the other session, Mr. Shroff from Excel Industries said that they were dabbling with phosphine. Just imagine, these are pyrophoric gases. Gases that explode when they are exposed to air. How do you handle that particular type of a hazardous chemical? Air is all around us. How do you create the environment in which this has to move about? Okay, these are all specialized trainings. And that is what we are actually talking of when we are saying we want to build skills for semiconductor manufacturing in the country. And not many people really understand what the semiconductor manufacturing industry actually entails. So let's go back to the presentation. Just go back to the presentation. So, Parashi, my presentation, PPT. So, Electronic Sector Skill Council actually is a neutral body. It's not a training institute. It's not an MTech. It's not an IIT. It's actually made up of professionals from the industry. The Sector Skill Council technical committee is made up from people from the industry who are guiding what is the curriculum to be built in for the job roles that are going to be there in the industry. Separately, I can get into details of it, but very detailed job ruling for the semiconductor industry was done. Very specific curriculums were developed for some of the roles. It takes an effort, as you can see, to make all these ones, but they are all in the pipeline, and they are all very interesting. And it is a very structured process that is done, where a national occupation standard is created, which is relating to a recognized job role, which has a very specific qualification pack or curriculum. And you have sensed the detailing in the previous slide, with a checklist of what will be considered as a skilled person, and with a very specific taxonomy under which the documentation has to be filed with the ministry to get it cleared. That is what a skill is. If the institute you're talking of is not following it, if it is not approved, it is not giving you justice. The whole objective of the programming is that the skills we create, they should be portable from, we're trying to see how jobs can be created. So industrial safety for semiconductors is a program which is designed for semiconductors, but it is portable to other process industries. Okay, that particular certification is designed for any potential job in India, but it is designed with an appropriate linkage so that a person can get absorbed in a suitable job abroad if required. So that is the whole programming action that is there. And that is what we actually need to build up. And we can do it from India. So I won't get into these slides. These are more how the accreditation and other things are done. Certifications are built up. I want to talk to you about this program, which we are going to conduct on September 9th. These are semiconductor manufacturing tutorials done at IIT Delhi RNI Park by Electronic Sector Skill Council and SEMI. So if you remember Semicon from last year, Semicon India, Semicon is a franchise of SEMI, which is Semiconductor Manufacturing Industry Association, a global body. And in collaboration with them, these programs are being done on 9th, and they're the primers. And there are two programs that we are doing. One is the industrial safety for semiconductors and display, where we'll actually take through, you start with a bang literally, a factory exploding out, and we'll show the fire and other works. And then we start getting into details. What happened at SCL? I don't think Surinder Singh ji is here, but way back, SCL, our nascent project in semiconductors, got burned to the ground because of a silent fire. Okay, when a silent explosion takes place, what is the safe distance to be away from it? Anyone? 1.6 kilometers, 2 kilometers. Okay, that is the nature of chemicals that you are actually handling. The gases are stored in bunkers to secure them from any potential fallout. Okay, now these are the sessions which will start building up. How you have to handle some of these hazards. What are the normal protocols for it? And what are the emergency responses that you have to take in? These are actually, there's another one on vacuum technology. Again, getting into a lot of details. How do you actually extend life of your diffusion pump oil? How do you make sure you get the maximum productivity out? Typically, reaching ultra-high vacuum can be a 2 to 3 day exercise. You play with something, it can actually go a lot more. You're working with equipment which is $1 billion, costs the exposure of having downtime on your equipment. This is where your skills will start coming in a different way. Controlled environments that you want to operate in. You can have a clean room. It sounds nice. I have a class 10 clean room across my entire factory. The cost is going to be prohibitive. You control your clean room to pockets, the class 10 to pockets, so that you manage your costs. That is engineering. Every aspect of your factory is planned, actually. If you see a sub-fab, you will be wowed by it. I've seen fabs. I can tell you, it's not the main fab, which is very clean. It impresses, but sub-fab is mind-blowing, where you actually see all the utilities, the engineering that is going to feed into the main fab. And everything is planned right down to the inch in design before the final thing gets created. So design matters, but these are all specializations. So all that I'm trying to say is there are some very interesting programming that is happening. Those of you who are from the academic background, those of you who are from the industry, please participate in it. This is a unique opportunity. What we will be doing is on 9 September, that's a Semicon week in India this year. Okay, 9 September are the tutorials at IIT Delhi RNI Park, Research and Innovation Park. 10th, there is a round table with the minister, and there will be something for academia in the evening. Okay, 11th, the main show goes on live, Semicon India show floor, the exhibition, and the conference. And post the conference, we expect to kick off a job fair. Okay, so academia, Just listen to that. Look at what it means for you. 12th, there is a workforce development programming in the morning with at the Semicon conference. 13th, there is an EDA tutorial. There might even be a display sector tutorial on that day. So very strong focus on academia, and capacity building will be there in those days. My clear recommendation, make sure you are engaged in, you're contacting, and getting engaged on these programs. Quick role view on Electronic Sector Skill Council. For those of you who don't know it, it is an apex sector skill council funded by the Ministry of Skill Development and Entrepreneurship and 6 industry associations. It is actually doing some very interesting work, and it is going to be one of the key bodies shaping the semiconductor manufacturing programs in the country. SEMI is its partner in India. SEMI hosts 3,500 global semiconductor industry members. Literally, every semiconductor industry ecosystem company is a member of SEMI. It owns a Semicon event franchise. That's why this year's Semicon is being done by SEMI. And there's an opportunity to create a global brand leverage with the SEMI University. There's a whole lot of work that is happening here. I don't want to get into details of it. The key message is there's a lot of action happening at this point of time. There are good leverages. Let's connect. Let's make it happen. Apunga time aa gaya. Cheers.
Thank you so much, sir. I would once again request Mr. Purani, sir, to please come on stage and felicitate, sir. That was a lovely, lovely presentation. Thank you so much, sir. Let's give a big round of applause to our speaker. Now we are moving towards the panel discussion, and first I would like to call on stage the moderator of this panel discussion, Dr. Sundar Manoharan, Director General, PDEU. Dr. S. Sundar Manoharan, an esteemed educationist and scientist with a PhD from IISc Bangalore, has dedicated over 30 years to teaching and research in material science and nanotechnology. He served as a professor at IIT Kanpur and was the founder director of the National Center of Nanoscience and Nanotechnology at the University of Mumbai. Welcome, sir. Our first panelist in this session is Mr. Pradeep Kumar Dikshit, Senior Manager, People's Organization, Micron. Mr. Pradeep Kumar Dikshit is an experienced HR professional with over 20 years in manufacturing, impacting the electronics, automobile, and renewable energy sectors. As Senior Manager of HR at Micron Semiconductor Technology India, he holds an MBA in HR and a Bachelor's in Electronics and Communication. Our second panelist is Dr. Nihar Mohapatra, Professor, IIT GN. Dr. Nihar Mohapatra, a professor in electrical engineering at IIT Gandhinagar, brings a rich blend of industry experience and academic prowess to the field of semiconductor technology. Mr. Jerry Agnes, CEO CG Semi, is our next panelist. Mr. Jerry brings 2 decades of experience in the semiconductor industry, having served as the country manager and president of Amcor Technology Philippines, a prominent company specializing in semiconductor outsourcing, assembly, and testing. Our next panelist is Professor Viresh Deshpande, Center for Semiconductor Technologies, IITB. Professor Deshpande has a distinguished background in semiconductor research with a PhD from CEA LETI, France, where he explored quantum effects in nanowire. He worked effects of nanowire. And now we have the next panelist, Ms. Bhanupriya. Ms. Bhanupriya came with over 15 years of experience in IT talent acquisition, has managed teams across India, the US, and Europe. And so I think we have got all our panelists on board now. Yes. Great. Sir, I would request you to start this session. Thank you.
Thank you so much. It's a joy to introduce all our panelists. I don't want to take any time for setting this topic on the motion because we have very little time. But we have 3 industrialists and 2 academicians. The questions are the intriguing questions that was raised by the last three speakers clearly says that the capacity building has to start from the academia. If you go to a temple, there are three courts. You just move around freely in the outer court and then you go to the inner court. But when you go to Holy of Holies, your restriction is there. You cannot just move around. You have to have a different code of conduct to go into the. So we are actually here to listen to the industrialists and the academicians as to how to equip our students and how to equip our engineers to be industry ready. And I want to introduce both the speakers from CG, Semicon, and as well as Micron. Mr. Pradeep Kumar Dikshit from Micron. He's the HR manager. And I'm going to switch the questions between the industry and the academia partner so that we will get enough time. Now, academia is placed with a very challenging, job. We have to create manpower for green collar jobs. We have to create for the blue collar jobs, and we also have to create for the white collar jobs. And that's where Bhanupriya ji will also tell us how we can go ahead with skill development courses. To start with, let me start with Mr. Pradeep Kumar Dikshit. Sir, thank you for coming. And
Thank you for the opportunity.
I just want you to give your perspective about what are the requirements now that you're a major player in Gujarat. What are the skill set that you're looking for, and what you would expect from academia?
Yeah. So currently, as you know, we are having an ATMP
Sure.
courses in the various universities,
You
and
can
also
keep
we
it
are,
closer.
yeah, and also we are making the backend processes, especially the module and the CAD, the component and the assembly side we are making. So we need the specialization in these areas. So practically 5,000 direct job and 15,000 indirect jobs we will create. In that particular job, 70 to 75% we will focus on the NCGs, which are the new college graduates. That constitute of the degree as well as the diploma holders.
Okay.
So we want these specialization in the degrees and diploma. So
Yes.
we are putting some more effort right now. So we had a ATMP course very recently completed, in which almost 400 students participated, and very shortly in the Jan 25, another batch will be started. So that's the way we are starting right now, the skill develop, kind of a collaboration with the academia right now.
Sure. Thank you. Now that you mentioned about 70% that you're looking for fresh graduates, I would toss this question to Professor Virish Deshpande, because Mr. Pradeep talked about 70% requirement from graduates, both diploma and degree holders. How do you see IIT can help in this manpower requirement?
Yeah, so predominantly we are, as you know, undergrad and a postgrad institute, whereas as a lot of the requirements come from diploma and ITI levels. But as you can see, where we really play a role, first of all, we have although semiconductors as an ecosystem is taking off at IITs and ISC,
Yes.
both from research and education, this has already been going on for several years.
Yes.
In the past, our students had to find jobs elsewhere. And so in terms of curriculum and how to teach it, what infrastructure is needed, we have been including it, and so we have the expertise. Now, what we can do is we can really mentor all these diploma teachers and basically what we call train the trainers program, in order to spread out the volume and ramp it faster, so that we have the infrastructure to get the trainers from diploma and ITI colleges over to us,
Yes.
whom we can train, and in a way how to teach these to at a various levels, so that they can go back and spread across India. And So that is one way we see to get it, ramp it up faster.
Yeah.
And the other way we can do it is for short batches, which had front-up batches which have been hired by industries already. In the short term, we are talking of next 6 months or so.
Yeah.
We can give dedicated trainings to several hundreds at
Yes.
least. And this we have already done with at IIT Bombay with Applied Materials. We had also did it recently with Tata.
Yes.
So, and we continue to do this for both packaging. There is one program we did, and
Yes.
also for FabTech.
Mr. Pradeep, you mentioned about ATMP in specific, this back-end process. So can you just tell a little bit about how you have engaged with the academia in training specific to back-end and in Gujarat, to be more specific?
So currently we have a tie-up with the PDEU, and with this university we are giving the machines, and already I think machine is on the way and probably reached out in the day or two.
By the way, he's talking about our university, and we are going to, machines have come, so we are going to launch this skill training from next month end. Yeah, please.
Yeah, and it will
But
be for
also LD College.
yeah, then I'm about to say that again. The similar way is the NAMTech and the LD colleges we are in the
Yes.
discussion with, and again I told you earlier that the ATMP batch is also going to the run. So these way we are in the tie-up with the various institute to run as well as the training colleges and the curriculum, both the way we are doing.
Yeah, this is exactly what I would say from leapfrogging to pole vaulting, because we were trained, our mindset was into more of a research, the academia, but suddenly we see Micron and CG and Tata coming and trying to set up the fab and talking not about 1 square inch silicon cells or wafers, suddenly talking about 4 inch, 6 inch, 8 inch and 12 inch. The academia need to pole vault now. And this can happen only when the gap between academia and industry is removed, or it becomes too narrow. So I'm very happy to see the initiative coming from Micron, and the readiness that our Professor Virish told, that on one hand we need to give hands-on training, but at the same time, like what we heard from Applied Materials, somebody has to run the course rigorously and in a way that Applied would like to see the course being enacted in the campus, because they cannot do, but it has to be done. Therefore, there is a highly complementary situation that exists at this point of time. It's not only machinery, it's not only about the investment, it's about the readiness to teach, the readiness to train. Professor Nihar, I'm going to come to you, but before that, let me talk to Mr. Jerry. Mr. Jerry, thank you. You're already there in session 3A, and I'm very happy to introduce Mr. Jerry, who is the CEO for CG Semicon. He had a great experience in Philippines before moving here. So I would say that if you can take a minute to tell about what happened, what was the story at Philippines, and what you intend to do at Dolira, that would be good.
Okay, to start with, I was hired by CG Semi, I would say 45 days ago.
Yes.
And the main reason why I accepted the job, because in the Philippines, semiconductor, we are the affiliated or the company being handled by the leading semiconductor in the world. To the extent that the company in the Philippines have 13,000 employees, 13000. And part of the subject that I would like to share with you is the more of the strategies that we have implemented to nurture the talent of the people in the Philippines. So you can imagine you have 13,000 people, both operators, technicians, engineers, and some of the top management. And one part of the strategies that we have implemented is of course, even here in India, I hear the collaboration with the top universities. That's number one. Because the skill set will be nurtured in the best school in the Philippines. So we have identified the gap of the requirements of the semiconductor compared with the regular engineering courses. So we have shared that as part of our strategy. Sorry. And the second one is training and development programs. The OSAT company in the Philippines, not necessarily Amcor, invest in training and development to enhance the skills of the existing workforce. Includes the technical training, management training. In fact, in the company that I handled, some of the engineers trained in the US and some in in Japan to take care of the Toyota manufacturing system. Anything that we introduce reflects the company's move to really prepare all the people, especially in the Philippines. And this is a very interesting subject, the employees' engagement and retention. At the height of the industry in the Philippines, we have so many IDMs. These are the internal device manufacturer, you name it. We have the big guys. You have Intel, AMD, all of the big guys in the IDM. So there is some retention program that they are doing. We also doing a lot of retention program. Retention program, just to give you example, I don't know if it's happening here. We have what you call the key technical employee. We call it KTE. So all the positions, especially in the technical community, we implemented the key technical employee. When you say key technical employee, the employee that we have identified because of performance, everything, we deducted voluntarily the certain amount, and the company will provide the amount as what the employee was deducting from his salary. And the retention program says, if you stay in the company for 5 years, you will get this amount. So those are the retention program as an example.
Mr. Jerry, yes, thank you. I want to just amplify what points you raised.
Yes.
Number one, I want to ask in specific to the ATMP facility that you are setting up at Dolira.
No, it's in. We are setting up a factory in
Sanat.
Gujarat.
Sanat, yeah.
This is actually
Yes. Yes.
assembly.
Yes, assembly unit.
Yeah.
Now, what sort of skill set that you would expect or training that you would like to engage with academia?
It's actually the engineering portion. We need the best engineers to manage the technical aspect of the job, because it's not easy. Because the requirement of a semiconductor manufacturing is different from the regular engineering courses.
Yes.
Because in the semiconductor manufacturing, you will hear a lot of words like zero defect. So mind setting is very important.
Sure.
So if I can cite a lot, but as we progress, we can see here in India that we will be nurturing the skills.
Yes.
And what we plan to do is that we should be identifying people, not necessarily from the Philippines, because we are hiring people from Malaysia. Of course, we have a local Indian engineers.
Sure.
And we mix that so that all the best technical people will be merged in the entire CG factory.
Sure. Thank you.
So that's the one that we are trying.
Thank you. Yeah. Mr. Nehar, I just want to ask you, especially in response to what Applied Materials was talking about, because we don't have industry working on the front end. Both of them are representing back-end technologies. what are the challenges that you think the academia would face in terms of skill training? Especially, he highlighted about high vacuum techniques, large area depositions. How fast we can scale up the skill training?
Yeah, very, very good question. So thanks for asking this question. Yeah, so currently, if you look at the most of the undergraduate curriculum, even at IIT,
Yes.
so we do not teach many of the courses which is the requirement of the semiconductor industry.
Yeah.
So when I talk about semiconductor manufacturing as a whole, as Dr. Agrawal also mentioned, it is a multidisciplinary subject, right? If I look at semiconductor manufacturing, it could be clearly divided into three parts. One is design, which we are not talking here. So other one is materials and devices, and the third part is semiconductor manufacturing. So currently in undergraduate curriculum, lot of colleges, even IITs have courses on materials, courses on devices, but there are very less number of courses, even no courses in semiconductor manufacturing. When I talk about semiconductor manufacturing, like Dr. Agrawal mentioned, vacuum technology,
Yes.
we taught students thin film deposition, but we don't go very detailed how to handle vacuums, what are the pumps
Yes.
required, and how to handle those pumps. And also, which is missing in the curriculum is the safety aspects of semiconductor manufacturing, which is very, very important. Like Dr. Agrawal also mentions before this panel discussion, the safety in semiconductor is the first thing that students need to learn before they enter any facility. So they need to learn about the safety, how to handle gases, how to handle equipments. So we need to have, if you are teaching semiconductor manufacturing, this process safety should be an integral part of
Sure.
the course.
Sure.
The other thing, which also I think none of the speakers mentioned, is automation, because semiconductor manufacturing basically most of the things happen automatically. Like we have tools, but we operate the tools from remote, right? So
Yeah.
in typical fab there are no people inside. So and this is basically done by automatic process control stuff. So we need to also see how to integrate, because we are talking a lot of things about artificial intelligence, machine learning, how to use this AI ML in semiconductor manufacturing, and how to handle these tools. So these are the things we need to integrate to the course which are thinking for semiconductor manufacturing.
But coming to the point of handling the wafers and going through the deposition process, how ready are we, or how intensive the infrastructure is for academia to respond to this
Yes.
need?
So as Professor Bires also mentions,
Yes.
so we have labs, but these labs are very small labs, small
Yes.
facilities. Most of us have around tools which could handle 4-inch, 6-inch wafers. They are not suitable for production, but for our research, we need this. We actually use these tools for research in material devices.
Sure.
But for the workforce development, we need the exactly same tools that are used in production fabs.
Yeah.
So at this point, none of the educational institute in India have these tools, and I think we should create a pilot line. I'll call it pilot line, with all the tools that can be used, that is typically used in a fabrication facility.
Sure.
Where the students so it should be done in 2 phases. So for the students, initially they will use the normal process tools. Once they train that, then they could they could use the actual production like tools.
Yeah.
So this need to be built up. And coming to the timeline, so this is the plan. IIT Gandhinagar is also talking to different industry leaders to have this kind of facility, and this may take, in my sense, around 1 to 1.5 years to bring that facility up and running.
Sure.
So
Sure.
till then, I think we need to rely on sending students to the fab locations in Taiwan or Malaysia or Singapore to be trained in actual facility.
Yeah, as Dr. Nihar said, I think the timelines are very crucial. Even if we set up the fab facility or a clean room facility, it would take at least 18 months to get it started. So it is a paramount challenge for the academia to rise up to the occasion. But at the same time, we can quickly fit the bill as far as back-end technology is concerned. It would hardly take another 4 or 5 months in order to set up a back-end technology training center. In the previous session, we were talking about a 6th-hour crisis dealing with environmental issues. I would say this is a 11th-hour crisis because we don't have manpower. So I would like to switch gear and give time to Ms. Bhanupriya. I think she's already working with Keynes and has done several skilling initiatives. Could you just highlight 1 or 2 of your engagements with Keynes, please?
Thank you so much, sir, for this opportunity. Hi, everyone. I'm Bhanupriya, representing Perceptive Solutions, partnered with Keynes Semicon. So although we have been, despite being a startup company, we have been engaged with semicon manufacturing and also semicon VLSI design part in their placement with various companies. So we have also started our engagement on the manufacturing training programs with couple of organizations. And to answer the question, so we have been associated with Keynes Semicon to give us small heads up how we actually operate us. So we started engaging a partnership with Keynes and gathered the requirement, what kind of plant they're putting and what is that their need and the requirement is on the manpower. So we then segregated the requirements based on the skill set, based on the expertise level, and then we approached the universities. And in Gujarat, we have been engaged or started associating with GTU, Ganpat University, and couple of them where we can start engaging the training programs. That is more on the theory at this point of time, considering the programs, what we are doing, we have started the engagement where we can start training the students how they can start engaging with their manufacturing sector and what kind of requirements Keynes has and what kind of requirements industry is going to come up with. Based on that, we have put certain curriculum, we have got certain trainers from Southeast Asia, and we have started training program. With one of the top MNC company, we have started our 16 weeks of training program where 44 new college grads have started their training program, which is already there. So which means we have already started. So that is something which we are contributing at this point of time.
Thank you, thank you. Is there any initiative what Dr. Ashwini had listed about the certification course, the safety course that he was talking about? Have you incorporated?
We have been associated with Electronic Skill Council, and we have been engaged in that aspect also. On the we are yet to work on the certification, but that is still on the progress.
Good. Please.
Yeah, so IIT Gandhinagar is planning to have a certification course in semiconductor process safety. So we are currently debating on that. So we'll very soon have this course. Also, we are planning to have certification courses on semiconductor manufacturing, also how to apply artificial intelligence and machine learning to semiconductor manufacturing. So these courses are in the pipeline. So once finalized, maybe we'll talk to Dr. Agrawal and his team also if our course content looks good.
Wonderful. There is a clear prelude to the semicon conference that's going to happen in Delhi, Noida. I think this is the most relevant session that we can think of because the need is great. The infrastructural demands are high, and so much so is the manpower training. We have not even touched on the aspect of research and innovation. We are struck only with the skill development issue because that itself is mind-boggling. Then to go from basic skill training and then to research and innovation, it's going to be a much more demanding exercise. And I'm sure both the industries who are represented here, they have left a pattern for us to follow. Because even before they commissioned their setup in Sanand, they are actively involved with the academia because they know that somehow the academia has to rise up to the occasion. So I clearly see the academia is a little bit wobbly because we actually have to pole vault, no more leapfrogging, and we have to probably even keep silicon wafer like a pillow and sleep. Otherwise, the dream will not translate because it's such a humongous task. But I'm very happy to see both the skill training initiated by the industry and the readiness with which the academia is responding, and other agencies who are also trying to bring the match between the industry and the academia. That's a perfect setting. For want of time, I want to bring this session to close because we have already exceeded time. But I'm sure you have identified the potential players both from the academia and the industry here. We have several rounds of talk we need to initiate because the other three speakers have left us with a lot of ifs and buts that can happen in the skill training. And you look at the slides from the HR chief of Tata Electronics. He was talking about academic council. To introduce a course and to get it approved and to certify it in a university is a process which can take 3 months. You cannot just like that serve it on the plate. So there is an inherent limitation to academia. At the same time, the most challenging issue is about the infrastructure readiness and the instrumentation that we have for such high precision processing. But I'm very happy that the industries are very gladly representing, hand-holding with the academia. I hope the next 1 year, or probably Semicon 2025, we will be coming with several case studies of how we have translated from ground zero and we have pole vaulted. Thank you so much.
Thank you.
Thank you so much to all our panelists and our moderator for this wonderful, wonderful, insightful session. Thank you very much. I would once again request Dr. V.S. Purani, Chairman, Technical Examination Board, who's also the session coordinator for this session, to come up on stage and facilitate all these amazing panelists that we have on board. So we'll start with Mr. Pradeep Kumar Dikshit, Senior Manager, People's Organization, Micron. Thank you so much, sir. Dr. Nihar Mohapatra, Professor, IIT Gandhinagar. Mr. Jerry Agnes, CEO, CG Semi. Professor Viresh Deshpande, Center for Semiconductor Technologies, IIT B. And Ms. Bhanu Priya, MD, Perceptive Solutions. And now to our wonderful moderator of this session, Dr. Sundar Manoharan, Director General, PDEU. Thank you so much to our moderator and all the panelists. I would request our speakers of this session also, if they are present, to come up on stage. Let's have a group picture along with the session coordinator. Purani sir, आपसे request करूँगी आप please यहीं रहिए. हम एक photo खींचना चाहते हैं, group picture खींचना चाहते हैं. Welcome. So with this, we conclude all the seminars and session for Gujarat Semiconnect Conference 2024. I hope the idea of promoting, motivating, and facilitating the semiconductor meet over here and bridging the gap between two industries have been successful, and people have gained, everybody who has attended has gained a lot of insight and knowledge about the industry, and looking forward to more contribution from everybody over here. Thank you so much. Thank you so much, Government of Gujarat, for giving me this opportunity. This is your host, Monica Singh, for today, who's signing off. Thank you very much. And if you're going back with a flight, have safe travels and drive back home safely. Thank you so much. Thank you. Take care.